Okay, where we left off on our last video, we were on this example where we had, I'd made a mistake. I'd tried to go ahead and subtract 2 from x plus 1 as if these were common denominators, but they're not. This has x plus 2, x plus 2. This has x plus 2, x minus 2. So you're timesing two different things. It's like you're 5 times 3 and 5 times negative 1. Different denominators. So to make them the same, we need to multiply. So they have a common factor, right? The common factor is x plus 2, but this has an x minus 2 and this has an x plus 2. So what I'm going to do is I'm going to multiply this side, the left side, by what's missing on the right side. Or let me use some more color here. X plus 2, we'll put a blue. X minus 2, we'll put a green. Yeah. How about a yellow, blackish? And then we'll say, okay, I need that blackish over here, so I'm going to multiply by x minus 2 on both sides over here. Excuse me, top and bottom over here. So that adds to what I already had, right? And then I'll x plus 1, and then x plus 2 squared. X plus 2 is the same as x plus 2 squared. Minus, so now to make this x plus 2 squared, see I'm missing this on this one. I only have one x plus 2 on this one, so I need to multiply by x plus 2 over here. So I'm going to say 2 times x plus 2. And then that way I'll have, now my x plus 2 down here can be squared because I multiply by x plus 2, both top and bottom. And then I started with x minus 2 already there. Now I've got common denominators. I'm going to multiply them out. So my denominator is just going to stay the same. That's going to become one common denominator. This is it. But the top, if I FOIL that first part, I'm going to get x squared plus 1x minus 2x minus 1x minus 2 minus distributive 2x plus 4 over same thing. And you don't need to write out the denominator a second time. You could have just made it one big fraction bar. But now when you do this subtraction, you need to make sure that you distribute the minus signs. You're minusing 2x and you're minusing 4. So if I can just maybe create some space up here, and I'll finish the problem right here. So x squared stays, I'm going to combine like terms to basically combine the numerators. X squared minus x minus 2x makes minus 3x. So we got minus 1x here, minus 2x is minus 3x. And negative 2 minus 4 is negative 6. That over that same denominator. Denominator stays the same, right? Yeah, Mr. Dittmer. Good job. That should be our final answer. Check on the book. Yeah, looks good. Okay, I'm going to pause for a second. That is this one with, it's a word problem. It says the distribution of heights for American men and women aged 20 to 29 will be modeled by these two fancy equations. We're just going to do part B of this example. X is the height in inches, and Y is the percent of adults aged 20 to 29 whose height is that. So basically, it's a fancy graph. It's a couple of fancy graphs, and part A says to basically show you those graphs, and there they are, right here. But we're not focusing on that, partly because my screen cap doesn't really look at that. But if you graphed each of these two equations, you would get these type. They look something like this. But the next question says, this is what we really want to work on because we're adding these things together. Write a model that shows the distribution of the heights of all adults aged 20 to 29. So it should be like, the men plus the women. So we want to add those fractions. So we're not going to want or need this. All we need is that. Those are the two things we need to add. You know what? Looking ahead in the book, I'm not even seeing that. The suggestion actually in the book is to add these two things and then divide by 2. And then they're not really having us simplify it. They're having you graph it on your graphing calculator. So I don't even know what it would look like to simplify. And that works out well because I'm out of time to record right now. So that's all I've got for adding and subtracting rational expressions for now. Make sure and ask questions if you need help. Thanks.